All right, here we go. So we're going to find both intercepts, the X and the Y-intercept. Now, I want you to notice something. There's already a hint there. Okay, when we're looking for X-intercepts, what do you notice about the Y value? It's 0, isn't it? Yeah, right? Because whenever something crosses the x-axis, which is what the X-intercept is, right? An X-intercept is where it crosses the x-axis. Along the x-axis, the y value is always 0, right? Because you're on the x-axis, you don't go up or down. You're on the x-axis, right? So the y value is a 0. Okay. Now the y value we also know to be f of x, right? So what does it mean, right? Okay. Well, sometimes we have a hard time here with function notation. So if you struggle with this, I want you to think of this f of x as just being y, right? Which means y is equal to 1/2 times absolute value of x minus 3 minus 4. Now, why is that helpful? Because now I know that y is just supposed to be 0, okay? But a lot of times I see the mistake where when you leave it in function notation, a lot of you write it this way, right? And then you kind of like get a little lost in the process. So what I would recommend is if we know f of x is the same thing as y, then I'm going to change f of x into y. And then I'm going to change that y into a 0 because that's what I need to do to find the x-intercept. Okay, so now this becomes 0 is equal to 1/2 times absolute value of x minus 3 minus 4. Okay, and this takes us back to unit 1 where we have to solve for x. Okay, so we're just solving absolute value equations at this point. Okay, so if I'm looking for solve for x procedurally, what would be the best way to do that? What could be like my first potential step here? How would I get x by itself? Multiply by 1/2. I kind of want to work my way like outside in. I can't distribute 1/2 because absolute value does not allow you to distribute inside. Let's start by, let's first move the 4. Yeah, so we have a constant here, a minus 4. Let's go ahead and add 4 first before we do anything else. Okay, that leaves us with 1/2 times absolute value of x minus 3 is equal to 4. Okay, now what do you think we can do? Maybe to get rid of the 1/2. Fraction buster, yes sir. So what do we multiply everything by? Let's multiply by 2, right? Let's multiply by 2. Okay, so I'm going to multiply the left side by 2 and then the right side by 2 as well. All right, so that leaves us with 2 times 4, that's just 8. 2 times 1/2, these will cancel. That leaves me with just absolute value of x minus 3. All right, now let's see if you guys remember. What happens from this point? How am I able to now solve for x? Give both variations. I like that, right? Split it. Yes, yes, you guys remembered, right? So we split. Okay, we're going to get 2 possible solutions. The first one will be x is equal to, 8 is equal to x minus 3. And the second possibility will be x minus 3 equal to negative 8. Good. Glad you guys remembered. All right, so now let's just solve for x, right? So in one case, we'll add 3 and we'll arrive at x is equal to 11. And then the next one, let's add 3 again. And then let's confirm x is equal to negative 5. Okay, those are my both possible solutions. All right, now let's say I wanted to make sure that these were valid, just in case, right? Because sometimes with absolute value, you never know. Right? You get a solution that you think is valid, and then it doesn't end up being so. What's one way to make sure that both 11 and -5 are correct intercepts? Yeah, we can substitute, right? We can go back, we can plug in and verify, we can check. Okay, now where would we go check? I would go back and check right here. Okay, when you set the absolute value equation equal to 0. Okay, so we can check here. All right, so we would have 0 is equal to 1/2 times absolute value of 11 minus 3 minus 4. Okay, we'll get 1/2 times absolute value of 8 minus 4. 0 is equal to, well, 1/2 times absolute value of 8. Absolute value of 8 is 8, and half of that is 4. So 0 is equal to 4 minus 4. 0 is equal to 0. That one checks out, right? So I know that I have x equal 11 as one intercept, right? So the first one will be 11, comma 0, right? That's my first x-intercept. Right now, it's very possible to have two, right? If you think about the shape of an absolute value, it's a V. It's opening up. Not only that, what do you know? It shifted 4 units down, right? So if it shifted 4 units down, your x-axis is here. You can see how it's likely that it intersects the x-axis at 2 different points. I'm not even sure if you guys can see me, but it's supposed to intersect at 2 different places because I can see how that V shape has slid down, and as the lines move up, it's going to intersect the x-axis in separate locations. Okay, we're just verifying to make sure that this is correct. All right, now let's double check the next possibility. All right, now we're checking when x is equal to -5. So 0 is equal to 1/2 times absolute value of -5 minus 3 minus 4. 0 is equal to 1/2 times absolute value of -8 minus 4. Now, absolute value of -8 becomes a +8, and then you would multiply that by 1/2, right? So then here you would get 4 minus 4 again, and 0 is equal to 0, so that checks out. Okay. So what else can we say about -5? -5 is also an x-intercept, right? It's a valid x-intercept. So -5, comma 0 is my other x-intercept, and then I would box these as my intercepts. Okay, and we'll take a look at the graph on Desmos in a minute after we find the y-intercept. All right, so we solve and then you check for them, all right? Because there will be times, sometimes, when your x-intercept might not be valid. Maybe, sometimes, okay? All right, let's check y-intercept, okay? Now with y-intercept, it's the opposite. With y-intercept, this is where the graph crosses the y-axis. And what do we know about one of the given values? Take a look down here. Yeah, the x is 0. That's nice because that means we just have to plug it in, and then we'll solve for the y-axis, the y value. Okay. So why is that the case? Well, if you think about the x-axis, if you think about the y-axis, right, vertical, right? If you're on the y-axis, you didn't move left or right, so your x value is 0. The only thing that changes is how far up or how far down did you go along that y-axis. So that's why x is 0. Let's just plug it in, and then we'll simplify it. All right, so we can still borrow this one where it says y is equal to 1/2 absolute value of x minus 3 minus 4. Since x is 0, we're just going to do a quick substitution here, replace the x with 0. So you're going to get y is equal to 1/2 times absolute value of 0 minus 3 minus 4. Oh, you have no space to do the work. Just go into the next box. Don't worry about it. Use up all the space you need. Okay, you can always go on the backside later. So don't feel constrained by your boxes. I know that it's a lot of work. Okay, or you can do it on the margin on the other side, whatever. Okay, just know where you've put it. All right, let's clean up here. So now we have, I'm gonna go up here too. See, I'm out of space as well. Y is equal to 1/2 times absolute value of 0 minus 3 is -3, and then -4. So now, when you take the absolute value of -3, that becomes a +3, and you're gonna multiply that by 1/2. Okay, then you will subtract 4. Okay, so what we get is Y is equal to, 1/2 times 3 is just 3/2 minus 4. You can do decimal if you want, or you can leave it as a fraction, right? This is one of the cases where a decimal will be acceptable because it is an exact value. It'd be 1.5. Okay, so let's just say you want to keep it as a fraction though. You would need to multiply top and bottom by 2/2 to maintain a common denominator. So then that's going to become 3/2 minus 8/2. So Y will equal 3 minus 8, you subtract the numerators, you get -5 all over 2. Okay, so your X-intercept would be 0, -5/2. And then you box this one. Any questions on this one so far? So Y-intercept is the easier one to find because you just plug in 0 for X. The other one requires a little more work, but it's exactly what we did in Unit 1. Okay, so it's just kind of like recalling what you know from what we did maybe like a month and a half ago or so. All right, now if you want to verify, right, finding the answers is good, but you want to verify, your biggest tool is Desmos, right? Because you can graph this and find out like, okay, did I calculate the intercepts correctly, right? So I want you to be able to do this algebraically, but I also want you to be able to know that you have a resource and you have a tool where you can go and you can graph it and determine, did I actually find the right intercepts? Okay, well, how do I know which ones they are, where to look for them? Okay, so let's do that. Let's go to Desmos here. All right, so we get Y is equal to 1/2 times the absolute value of X minus 3, and then -4. Oh wait, oops, made a mistake. The -4 is on the outside. Okay, so you see, I knew that the -4 meant that I had a vertical shift down on my V. When that happens, when the V opens up, it's gonna hit my X axis at 2 different locations, right? And we found 2 of them. The X-intercepts that we found was, one of them would be at -5,0, the other one would be at 11,0, right? So along the X-axis at -5 and 11, you should expect the graph to cross those points there, right? Let's see if that's true. Well, if I zoom in here, well, it looks like there is that point, right? -5,0 is the first X-intercept. And then if I look on the other side, I have another point there, and it turns out 11,0 is also the intercept, right? So this is a great way to verify that what you've done algebraically is correct. Okay, now I will ask you on a quiz to calculate the intercepts. I want to see the algebra, but this is how you can always go back and check your work, right? And then if you look at what's the Y-intercept, Y-intercept, where does it cross the Y-axis, right? So I'm looking at this point right here. okay, is 0, comma, negative 2.5, right? So we got negative 5 over 2. It's the same thing as negative 2.5. It's just the decimal version, okay? So isn't that pretty neat? You can always check your work this way. And you can see if you're right or not. Okay, makes sense? All right. So algebra first, then you check on Desmos. No matter what, check your work on Desmos. That's what the tool is there for, okay? It's not cheating if you've already done the work, okay? And if you did it wrong, well, you still got to fix the algebra anyway, right? So there it is. All right, let's move on now. Let's take a look at example, what is this? 5, example 5. All right, so let's take a look. What are we gonna do first? I wanna find the X-intercept. When I wanna find the X-intercept, what am I gonna set equal to 0? What am I gonna replace with a 0? Remember that we can rewrite it as Y. Okay, yeah, so when we're looking for the X-intercept, the Y is the 0, okay? So you replace Y with 0. You get 0 is equal to negative 3 over 2 times x plus 4 minus 2. All right. What should we do from here? All right, let's add 2. I like it. 2 will be equal to negative 3 over 2 times absolute value of x plus 4. All right, now what? Fraction bust, okay. So what do we want to multiply to both sides? All right, let's multiply both sides by a 2. I can do that. Okay, 2 times 2, that's 4. When you multiply the 2 here with the fraction, the 2's cancel. So then what you're going to bring down is negative 3 divided by, negative 3 times the absolute value of x plus 4. Why do we multiply by 2? Because you want to get rid of the fraction. You want to get rid of the 2 in the denominator where you have negative 3 over 2. You want to get rid of that. Okay, now what? Where do we go from here? Do we split right now? Is there one more thing we can do before we split? Yes, so that, remember, this negative 3 is a product, negative 3 times absolute value. So in order to get rid of it, you would have to divide by negative 3. Okay, so those cancel. You can bring down, this would be negative 4 over 3 is equal to absolute value of x plus 4. Ooh. Do you guys remember? What kind of scenario have we run into? The absolute value is equal to what kind of number? And is this even possible? Yeah, it's equal to a negative value. Is it possible? Can the absolute value of anything equal a negative? All right, never. No, it can't, right? Because anytime, whatever I plug in for x and I add 4, when I take the absolute value, it's going to come out positive. So it's not going to equal a negative 4 over 3. Okay, so in this case, there's no solution here. And if I have a no solution, what does that mean about my X-intercepts? Do I have any X-intercepts? Yeah, so no solution, no X-intercepts. Now, why might that be the case? Let's go back up to the original equation. Let's see what the transformations are telling us. What do you notice about this and that? Which way is this thing? Which way is this V opening? Up or down? It's opening down, right? So reflection across the x-axis, and then what happens? What does the -2 make it do? Shift down. So if my x-axis was here, it first of all, it reflected over, and then it shifted down. Is it ever going to hit the x-axis? Yeah, it doesn't, right? So let's confirm that on Desmos. So we had -3 over, why does it do this? Okay, -3 over 2 times the absolute value of x. What was on the inside? +4. But then a -2 on the outside, right? Yeah, I'll go back after. But do you see that, right? It's a reflection which caused the absolute value to open down. And then not only that, it shifted 2 units downward as well. So by doing that, I'm not going to be able to intersect the x-axis. I will be able to intersect the y-axis, right? But not the x-axis. So when I say that there's no solution, and then there's no x-intercepts, it's because the graph has been transformed in a way where it's not going to hit the x-axis anymore. We do have a y-intercept. We just have to solve for that one, right? You can tell right here on the graph that there is one, right? You can see where it crosses the y-axis. We just don't know what it is right now. We'll solve for it. Okay, so possibilities are endless, right? Pretty cool. Okay, so let's go back. Let's go back here to this one. So now we know, okay, we don't have x-intercepts. That makes sense. So there are no x-intercepts. And that has to do with the transformation, okay? Now with y-intercept, let's go ahead and do that too. Okay, so we have y equals -3 over 2. We're gonna plug in 0 for x. Okay, so 0 plus 4, and then -2. All right, now we just solve for this one. This should tell us what my y-intercept should be. Okay, all right, so let's go ahead and do that. I have -3 over 2 on the outside. Absolute value of 0 plus 4 is just 4, -2. Absolute value of 4 is just 4. And I can multiply that by -3 over 2. And then I'll subtract 2. So -3 over 2 times 4. This is just -12 over 2 minus 2. And then -12 over 2 is -6 minus 2. So where does it hit the y-axis? It hits the y-axis at -8. Okay, so my y-intercept would be 0, -8. And then you can box this one. All right, any questions on that one? And then we can go back and confirm it too on Desmos, right? So you can see here, there it is, 0, -8. That's my intercept on the y-axis. All right. Okay, so I'm gonna give you a little bit of time to work on one on your own. All right, so now that I have my function rewritten, I can go ahead and change y with 0. So I can say 0 is equal to -2 times x minus 3 plus 4. Okay. And you probably should have gotten 2 x-intercepts in this case, okay? We'll talk about why. So now I have plus 4, which I can move over to the other side by subtracting 4. Negative 4 is equal to negative 2 times absolute value of x minus 3. Okay. Now we can see there that, well, negative 2 times absolute value of x minus 3, to get rid of the negative 2, we can divide by negative 2. And the great thing about that is that on the other side, negative divided by negative goes back to being a positive, right? Which is nice because it actually allows us to solve. So we should have gotten 2 is equal to absolute value of x minus 3. Okay, from there we split, and we'll probably get those 2 x-intercepts from there. Okay, so we split up here. 2 is equal to x minus 3, and then also negative 2 is equal to x minus 3. So let's see what those x values will be. Okay, we can add 3 to both. X is equal to 5. If I add 3 on this one, x is equal to 1. Good, right? So what are my intercepts? Well, my 2 intercepts are not just what x is equal to. The intercept itself is 5, 0 and 1, 0. The intercepts are points, right? So even though this is technically algebraically correct, you're not entirely correct until you've converted my solution into an intercept. Okay, so for both, right? So now I can say, okay, these are my x-intercepts. These are my solutions, because that was what I was being asked to find, okay? All right. For y-intercept, who are we setting equal to 0? The x, right? The x. So this one's kind of easy. You just plug it in, right? So we have y is equal to negative 2 times absolute value of 0 minus 3 plus 4. And all you need to do is clean up the right side, okay? So we have negative 2 times the absolute value of negative 3 plus 4. The absolute value of negative 3 becomes a positive 3, and then we would multiply that times negative 2. Okay, so whenever it comes out of this absolute value, it's still a product. And then we can add 4. So negative 2 times 3 would be negative 6. Then you add 4. So what we get is y is equal to negative 2. Okay, so that's going to be 0, comma, negative 2. That is my intercept right there. That's the y-intercept. And then, of course, you confirm it, right? You check it to make sure that all 3 of these intercepts, 2 of the x-intercepts and the 1 y-intercept are correct, right? This is one of those places in math where we encourage you to check your work, all right? And you can do it by checking graphically, right? You don't always have to check your work algebraically. So here we go. We want to graph negative 2 times absolute value of x, what was it? Sorry, x minus 3 plus 4. Okay, there it is. So now just to confirm, x-intercept at, y-intercept at 0, negative 2, x-intercept at 1, 0, x-intercept at y0. Okay, and there it is.